All right, guys. So welcome back to another session. And today we are going to move a little further into algebra. And we're now going to be looking at brackets. Now, brackets, we would have met before because we had met brackets when we were looking at bedmass. And we say that whenever we're carrying out operations, when we're adding, subtracting, multiplying, etc., we need to do it in a particular order. And so we say wherever we have brackets, we must first work out what is inside the brackets. So that's a rule when we're actually carrying out order of operation. So that is to ensure that we get the correct answer. All right, but today we are going to be looking at brackets based on the distributive property or the distributive law, which you should also be familiar with because we would have gone through those laws from early on. So we looked at the commutative law, the associative law, and we also look at the distributive law. And just to see whether or not anyone has that stored in their memory, can anyone give me what the distributive law states? Or if you cannot state it as how you have learned it, can you tell me what it means in your own words? Do we have any volunteer, or should I just call on someone? All right, so there's no volunteer. That means I'm going to call on someone. Miss Williams. Good evening, Miss Williams. Miss Williams, are you there?
Yes, sir.
Can you recall the law?
I'm not hearing you, sir.
Can you recall the distributive law?
Sir, the distributive law states that if I can't find my glasses, I'm trying to find my glasses and I don't know where it is.
All right. Miss Clark, you may go ahead.
Good evening, sir. The distributive law is where multiplication is being distributed over addition for a set of numbers.
All right. Anybody else agree with Miss Clark?
What you say, sir?
Would you mind repeating yourself, Miss Clark?
No, sir, I don't mind. Distributive law states that multiplication is distributed over addition for a set of numbers.
All right. Anybody remember that law? Ms. Waysome, are you in agreement with Ms. Clark? Apparently persons are not responding to me. What happened today? Miss Bellani. Miss Bellani, good evening.
Yes, sir.
Did you hear Miss Clark's did you hear what Miss Clark says about the distributive law just now?
No, sir.
Okay. Do you know the distributive law, Miss Bellani? Can you recall it? All right, never mind. All right, so I hope this will come to your attention that from time to time you really need to go back and look at these definitions and law. Even though we are doing, you know, kind of a procedure when we're solving problems, and generally we try to practice based on the procedure, we should also try to remember the laws and the concepts and so on, because with those, you can have better clarity and confidence in what you're doing, because you know exactly why you're doing what you're doing. So I'm suggesting that whenever you do get the chance, just review some of those information that you get on the notes, because the thing is with mathematics, it's connected. So whatever you learned before will follow you right through the entire, all the different topics, right through the entire syllabus. You will see connection with what you would have done in some topics with some other topics. So please don't put aside what you would have learned previously in isolation. You need to keep it fresh in your mind so that when you are dealing with any other topic that relates to that, you can incorporate what you know. All right, so just a word after. So Miss Clark was quite correct. The law states that when you're multiplying brackets, anything in brackets, it states that multiplication is distributive over a set of numbers being added or subtracted. That's what the law really is saying. Now, the distributive law is really more commonly used when you're dealing with algebra, but it also it is relevant just the same when you're doing arithmetic, right? So just before we get into the notes, let me give you kind of an example of what I'm saying, right? So let's say that we have, say, 3 brackets 2 plus 4, right? Now, what you would have learned from BEDMAS is that you work out what is in the bracket first. So in this case, you would add 2 plus 4. Then now you would have known also that whenever you have a number beside the bracket, there's an invisible multiplication sign between the bracket and the number. So if you work out what is in the bracket, 2 plus 4 give you 6. So this becomes 3 times 6, which is equal to 3 6s, students.
18, sir.
So that is equal to 18. All right. Now, with the distributive property, if we are multiplying what is in the bracket by what is outside the bracket in a distributive sense, it means then what we do in that case. Anybody remember what the word distribute means? what it means to distribute.
To share something
Here.
equally, sir.
So, say that again.
Share, sir.
To share. Is that what you said, Miss Baloney? Miss Baloney?
Said to share something equally.
To share something equally. All right. It not necessarily have to be equal, no. Distribute really means giving out, right? Sometimes you can distribute equally based on, you know, if you decide to do that, but distributing is really giving out, right? Sometimes you might distribute based on status, or our needs, our wants, or so on. But anyways, apart from that, if we are going to multiply what is in the bracket distributively, it means that each term within the bracket will be multiplied by the 3. So it means that if we are multiplying, we would multiply the first term 3 times 2, kind of like giving a 3 to a 2. So we say 3 2s give you what? 6. And then now, keeping the plus sign, we can now distribute, multiplying. We can distribute a 3 to the 4 in multiplying. So we say 3 4s. 3 4s give you what?
3 4 is 12, sir. Yes, it is
Right.
12.
And so if we add the 6 plus the 12, we see that we arrive at the same answer as before. We will get what? 18. Now, so what this tells you, that applying the distributive law can give you another way of multiplying brackets without actually summing what is in there. And it is more appropriately used in algebra, because whereas here we have specific values of what we have in the bracket, we know we have 2 and we know we have 4. But in algebra, where we are using unknowns, then what we might have something like 3 bracket A plus B Now, in this case, we really don't know what value A is or what value B is. And in terms of adding A and B, because we don't know what the values are, we really can't add, we can't simplify to get a single term, right? So what we have is the 2 unknown with a plus sign between them. Now, in that sense, we can't reduce it to a single term. So we have what we call an expression. And an expression is a group of unlike terms being added or subtracted from each other or together. So this, what we have in the bracket here is an expression. Now, if we were to multiply this, we would want to do so in a distributive way. So we can multiply by multiplying the 3 times A, we get 3A. And then the 3 times B, we will get 3B. And we know that if we know what A is and we know what B is, we would arrive at the correct answer. All right, so in algebra, you may find that wherever we have brackets, we can always multiply what is inside in a distributive way. All right, now that also means that when you have expression in brackets, the expression really representing a single value. So the expression A plus B means that if you have a value for A and you have a value for B, you could just add them and get a single value. So using the bracket in this way really must be treated as a single term, right? So if you have an expression in brackets, the entire bracket must be thought of as a single value if you are given value for those terms. Is that clear, guys? Let me see your hands if you understand clearly what I'm saying. All right, so I only see a few hands. Does that mean that there are persons who still weren't sure of what I'm saying or who are not sure? All right, just for the sake or the benefit of those who didn't answer. So let me say that again. If we are using brackets with expressions within the brackets, we must always treat that bracket as a single term, meaning that this bracket would reduce to a single value. Now, if you look back from here, when we add what is in the bracket here, 2 plus 4, we get a single value, which is 6. And so, give me a second. All right, so as I was saying, so if you have values within the bracket, you could easily add them. In this case, we could add the 4 plus the 2, and we get a single value. So when we actually put an algebraic expression in brackets, the bracket is really saying that simplify or calculate what you have into a single value. But because we really don't know what A is and what B is, we just leave it within the bracket. But what it really means is that given a value for A or given a value for B, you first have to reduce what is in the bracket to a single value. And so you would now be able to multiply 3 by that single value. Now, wherever we don't know the value for A and B, that's the reason why we will allow for the distributive property by multiplying each of them distributively, right? So other than that, if we have value assigned to A or value assigned to B, we should put in those values, add and reduce it to a single value, then we multiply. As the rule would have said, work out what is in the brackets first. All right? Everybody understand that now? Is that clear? I know I sound a little hoarse and a little husky. But I'm sure that you can hear me well and you should be following me. All right, so with that said, we are going to move on now to look a little bit further on what we're dealing with here. All right, so brackets are used for convenience in grouping terms together. There are some rules that we have when we are removing brackets. And the first one is when removing brackets, each term within the brackets is multiplied by the quantity outside the bracket. Now, basically what this is really telling you is that you should apply the distributive law. So the first rule is saying, whatever you have in the bracket, multiply each of them by the term outside the bracket. So that's really the distributive law in a different way, right? All right, so that's rule one. Rule two says, when you have a minus sign in front of the bracket, or if you rather, when you have negative sign in front of the brackets, that means that the number outside the bracket will be negative. Then all the term inside the bracket, the signs will change whenever you remove the bracket. So that's what this is saying. So once you are multiplying distributively by a negative value, the sign of the values inside will change to their opposites once you have done the distribution and multiplying out. All right. So that's rule number two. So that's something that you can bear in mind, that once you're multiplying any sign by a negative, you will get the opposite sign. So if you're multiplying a positive by a negative, the answer going to be negative. If you're multiplying a negative by a negative, the answer going to be positive. All right. Now here we have the third rule that says, when simplifying expression consisting of brackets, first remove the brackets and then add or subtract like terms together. All right. Now, so this one is saying that if you have more than one bracket in your expression, you can remove brackets from each by applying the distributive law, and then whatever terms you have after you have done so, you group like terms together, add them or subtract them wherever necessary. And the fourth law again is really, this is really distributive law written in an algebraic form, right? So all this is showing you that whatever you have in the brackets, if you multiply distributively by what you have outside, A times B, you will get AB. You maintain the same sign that you have in the brackets. Then A times C, give you AC, and you'll get this. All right. Now, remember now that the sign that you have in brackets will remain the same once the value or the term that you're multiplying is a positive. So once this is positive and you're multiplying by a positive distributively, whatever sign you have in the brackets will remain the same once you have carried out the distributive law. All right. Now, another thing to note is that you can think of A times B bracket C. You can think of that as a product, right? Now, remember we say that if you treat the bracket as a single unit, then you could, for instance, call the bracket by a single letter. You could call it, let's say, call the bracket X. Then what you'd really have here is A times X. All right, and so if you have A times X, this is really a product. So if you have A times bracket, you really have a product. Everybody see what I'm saying? Raise your hand if you understand that. All right. Now, so what it means then, when you multiply out distributively, A times X, your product after multiply out what is in the bracket will be equal to this. So if you multiply A times B plus A times C, then this is the result. Now, generally we would say when you're removing the bracket, we generally say you're expanding the bracket. So when you're expanding the bracket, you will get the distributive multiplication, and you'll get each term based on the multiplication. Now, why I'm making this emphasis here that this is a product, because we know that what are the things that we multiply to get the product? What we call them?
Factors, sir.
Factors, right? You call the thing that you multiply to get the product factors. Now, I just want to plant this idea into your head from now, so that when we move on to the next topic, then you can see exactly what is really happening, right? There is a topic that we'll be moving on to next that is referred to as factorizing, right? So now I want you to look at this now. So what you're doing, you're multiplying two factors. In other words, you're expanding the bracket, you're removing the brackets, and this is what you get. Now, once you get this, these are just terms added. So this become a single term. So all of this become a single term. So this is just the one term that you get from the result. Now I'm going to give you an example using numbers, right? So if I say 3 times 4, what do we get for the product? When you multiply 3 times 4, what we get?
12, sir.
12. All right. Now, the result here that we get would be 12, which is a single value. So these are the factors, 3 and 4, they are factors. So factor times factor give you product. Now, there are times when you might have the product, and we might ask you to find factors of the product, right? What are some factors of 12? So you're going to choose numbers that multiply together to give you 12. So we can find 3 and 4 as factors of 12. So we can multiply 3 times 4, give it 12. Now, the fact that you can find factors of 12, the process of finding factors of 12, what we're really doing is factorizing. So if I say find some factors of 12, you would probably come up with 3 times 4. You would probably come up with 2 times 6. You would probably come up with 12 times 1. And these would be what? Factors of 12. So in other words, by finding these values, you're bringing back factors together that you multiply to get 12. So the process of getting these numbers we are really doing what we call factorization. Now, what that means for brackets now, it means that A is a factor, the bracket is a factor. When you multiply the A times what is in the bracket, you get a single result, which is an expression. Now, when we multiply distributively, we are removing brackets. But you'll find out that the next topic, we will be looking at the expression and then now factorize to put back the brackets. So factorization is really the opposite of removing the brackets. So I hope you are seeing that, because oftentimes in math, what we do is we teach you the thing to go one way, then we ask you to reverse the process. So factorization is a reversal of removing brackets. So I want you to bear that in mind so that when we are looking at that topic, you understand exactly what we're doing. All right. Now, continuing with brackets. So here we have some examples that we're applying the rules. So remember that rule number 1 says that whatever we have outside, we multiply each term inside by that number or our term that we have outside. So simply, we're just going to multiply 3 times x